Let's start with an example of iterating over an array. In this example, I'm not going to be using an actual iterator, I'll just be using a pointer, but we'll use this as a first step towards using actual iterators. So in this example, I've written this print in order method that, given some pointer and given some known size of the array, will print all of the elements of the array. Notice that I'm not actually giving in the array itself, I'm just giving a pointer, which I will assume is pointing to the first element of the array. So here, int pointer p is this int pointer p, and it's pointing to this element. So basically, for each element in my list, so from I equals 0 to I equals size minus 1, I'm going to print this. This is dereferencing, so this is a dereference. I'm dereferencing the pointer, so I'm following the pointer, getting whatever number is actually there, printing it, and then printing a new line character. And then here, this is an example of pointer arithmetic. Basically, if I increment a pointer, it'll add 4 or add whatever size of the value type that is pointing to the pointer. So remember, a pointer is just a memory address. It's just storing some location in memory. And when you increment it, whatever size it's pointing to, so in this case, this is a pointer to an int, so it'll add the size of an int to its value, which is a memory address. So let's say its value was originally, for example, 9500, and we know that in many distributions of C++, an int is 4 bytes. This pre-increment, this would increment by the size of an int, because this is pointing to an int. So afterwards, it would become 9504, which would be pointing to this one, the next spot in memory. So hopefully that's clear. Let's walk through what actually happens, though. So we start with p pointing to the first element. That's how it is initially. And then for each element, so size in this case would be 1, 2, 3, 4, 5, 6, 7, 8. So iterate this loop 8 times. We're going to print whatever p is pointing to. So we're going to dereference p, follow it. Oh, that's the integer 10. Print it out. We get 10. Then we're going to increment. So this will now point to the next item. We go back in the loop, dereference p, so follow the pointer. It's pointing to 20. Print it, and then increment p. Next iteration, dereference p. It's pointing to 25, so we print 25. Increment, so now add, in this example, 4. Add the size of an int to the pointer's memory address value. Now we dereference 30, increment my pointer, print 46, increment my pointer, print 50, increment my pointer, print 55, increment my pointer, print 60, increment my pointer. It's pointing to something that's not actually part of my array. It's pointing to garbage right now, but my termination condition my condition is now false, so I can now terminate my loop, and I don't try to access this position. Now I'm done printing this. So we saw that I was able to have a pointer to a given element, dereference that pointer, and then increment that pointer. So what did I have? I was able to dereference my pointer in order to access the actual data value that it was pointing to. I used the data value, so dereference to get the data, then I used that data value in whatever way. In this example, I was just printing it. And then I incremented my pointer. So incremented the pointer, it was pointing here. I incremented it so it was pointing to the next data value, and then repeat. Dereference, use the data, increment. Dereference, use the data, increment, etc., etc. So in this example, because I was using an array, so the data were all contiguous in memory, right? The data values were int, immediately followed by an int, immediately followed by an int, etc. Because my data were contiguous in memory, because it's an array, I was able to use a pointer and just easily increment it. Can I somehow use the same exact notation for some non-contiguous data structure?